All right, guys, we're gonna start now. First of all, hi guys. I just want to say thanks for coming today, because I know Theory Club also has like this really cool panel and stuff, but you're here at the Better Club anyway, so hopefully I'll make your time being here worth it. Just a few announcements before I actually start. We actually have a bunch of companies already lined up to come in and talk to us this semester, so you can get excited for our next few meetings. We've got Home Depot potentially coming in. We've got Accenture and even GTRI and a few other places, so the semester is going to be pretty exciting. Anyway, also, as we're planning out the rest of our meetings for the semester, if any of you are interested in running for president or a similar position for next year for Grey Hat, please talk to me sometime about presenting at least one thing throughout the semester. I do ask that you present one thing just because if you're going to be president and maybe give presentations, it'd be good to give like exposure to see how well you are and just get ready for any kind of election we might have. But other than that, I guess we'll get started. So, topic of our presentation today is just on how to be invisible on the web, Tor and VPNs. So, Tor and VPNs are probably terms that you've all heard of or at least come across in some context while you're at your CS or whatever undergrad education at Georgia Tech. But surprisingly, a lot of people don't really know how they work or what you might be using them for. So today, I just wanted to give you kind of an introduction as to how you can use them and what they're kind of used for. So to kind of motivate why we have Tor and programs like Tor, we'll start by just asking ourselves, who wants my data? So you hear about like people who are always collecting your data when you visit websites or surf the web in any form or fashion. But what kind of data are they actually collecting? So some of the famous offenders are obviously probably going to be like Google or Amazon. So I don't know about you, but when I browse my Facebook feed, I tend to see like advertisements on Amazon for things that I just Googled, and I always find that like pretty creepy because it's like, okay, fine. But these are things that you probably come across. They're always collecting data on you when you're on the internet, as long as you're logged into your accounts through your cookies, through JavaScript code that's running on your browsers. So whether you think that's a good thing or not, it's happening in the background. Who else wants my data? The FBI wants your data. The CIA wants your data. So, I mean, this has kind of been in the news a lot in the past few years especially. But the government wants to be able to see what you're doing on the web, what kind of things you've been searching up, so that if you do happen to do something that they don't kind of want or they don't really like you're doing, they know about it and then they can stop you potentially. And of course, the obvious, the NSA. Also, a quick aside, I just saw this posted on Twitter like a few days ago. Yeah, I thought that was pretty funny too. But aside from those guys, who else wants your data? Well, if you're famous, maybe everyone wants your data. So if you remember, there was like a famous hack of, I think, Apple's iCloud a few years ago on many celebrities, and a lot of their photos were published online. So your data is pretty much never safe when you're online. And we're kind of trying to motivate why you might want to be anonymous on the web. So what kind of data are we talking about? I mentioned my example of my Facebook feed and the things I've searched for that I want to buy. You can like search this online to see exactly what kind of data they're collecting, but just a small sample of things you might be able to find are like, what kind of things do you click? What positions on the page are you clicking at? What are you typing in? What is the IP address you've come from? So you might see all these advertisements that are kind of localized to where you are from. For example, like maybe you'll get ads like, oh, did you know about this new law in Atlanta, Georgia? about your car insurance, and then they kind of want to target you because they know your IP address is in from that range of IP addresses. So there's a lot of information to be gleaned from different companies and what they're collecting from you just as you go on the web. How many of you have used this feature on your iPhones? Okay, some of you are shy because you probably don't want to admit it, but I know at least some of my friends have used this. This is kind of like the Find My iPhone application. So what it lets you kind of do is actually see some of your friends' locations as long as they have this app running on their phone too. So maybe you're at your apartment and you're wondering, like, where's my friend right now for whatever reason. All you had to do is pull up this app and you can actually get all their geolocation data and find out where they are. So you might think, like, okay, I'm not really doing anything. Why is this such a huge issue? But in the event that you do want to be doing something that maybe you don't want your fellow companies to be knowing about or the government to know about, this is really bad for you. Okay, even if you don't care about all of that, anonymity is one of the best ways to promote free expression. And that is because you don't have to fear what people are going to think about you or what they want to know about you. You can just express whatever you want and no one will know that it's you, so there's no consequences. It provides a voice for any unpopular opinions you might have. And maybe if this is what you're interested in doing, it lets you do some kind of questionable things that we might talk about later. Some argue that it's actually kind of unavoidable. So technology is progressing. We have more and more outlets to be able to do this kind of stuff. Might as well kind of start learning with it and getting with the times. And it kind of gives you knowledge anyway. So even if you don't support it and you think the government should be able to tell what you're doing in the name of security, might as well know how people who are trying to break anonymity do it, so that you can also, maybe you want to work for some 3-lettered government agency one day, and this is what is kind of aimed at teaching you. Okay, so how can you be anonymous? Obviously, you could walk around wearing ski masks all day and black hoodies and sunglasses, but what I'm here to tell you is how you can be anonymous on the web. So there's a lot of cool little tricks that you can do with your operating systems and your computers to kind of enable this anonymity. So for example, using virtual machines is a very powerful tool because no one knows if that's your host machine or not, if that's even what you're viewing the content from. So if you happen to download content that might not be safe, it's not running on your host machine, so if they're trying to track you in some form, it's fine. You can just delete the virtual machine. You could also disable any JavaScript code from running on your client-side browsers, because this code is what's kind of enabling non-static content to be running on your side. So if you were here for our Monday meeting, we actually kind of went over some of the harmful types of JavaScript that can run on your browser, such as cross-site scripting. So we were able to change the locations that the browsers were pointing to using that. You might also consider using throwaway email accounts if you don't want to have Gmail or Yahoo or whatever kind of tracking you. But today what I want to talk about is specifically Tor. So how many of you have actually used Tor before? Okay, so that's actually a fair amount. So if you don't know what Tor is, don't worry, I'm going to go into that in a bit. But other than that, we can also use VPNs, proxies, and encryption. So I won't go into proxies, mainly because proxies aren't really a great way of trying to be anonymous, because you kind of have to trust whoever is providing your proxy to deal your data kind of appropriately. And depending on the proxy provider, there's tons of them available for free, but it's generally not regarded as like a safe way to be anonymous. Okay, so what is Tor? Tor stands for the Onion Routing Protocol or Network, and it's basically just a way to talk on the internet anonymously. So it started out as kind of a government project back in the 90s, but eventually ended up becoming an open source project. So any one of you could contribute to or use Tor now. And it's totally run by volunteers, which is kind of the coolest thing. It's not like you have to go work for Tor to become a part of Tor. It's run by people like you and me who are just interested in free speech and allowing anonymity to exist on the web. There is this kind of cool URL, but I'm just going to skip that. If you want to see that later on your own time, you can. It just gives you a 1-minute overview of how Tor works, but I'm going to do it better anyway, so. All right, so how does Tor work? Let's say you want to connect to the internet. Well, the normal process is your computer is assigned an IP address by maybe your internet service provider, and in your IP header packets, you're going to have your source IP and your destination IP address. That's going to get routed or sent to your internet service provider. They'll know my IP address, so they'll be able to tell who I am since they can see that, and they'll know who I'm trying to go to. Then they'll forward it and route it through the internet, and eventually, whatever website I want to end up going to, I'll go there. Okay? So that's how the internet normally works. And with our normal procedure, the web server I'm going to knows who I am, and it knows that I want it to go there, and so does anyone eavesdropping in on any of these links. They all know who I am and where I was going, including like the government or any unwanted parties. Now with Tor, we're going to try and change things up. We don't want the government to know where I'm going or where I'm coming from. So, and when I say government, I mean kind of any party that is interested in knowing where you are. I don't have anything against the US government. But, so let's say I have my source IP address now, and I want to go to some website, but I want to do it anonymously using Tor. What I'm going to do now is not just connect straight to the web server, but I'm instead going to connect to a Tor node. So my ISP will see that I'm connecting to the internet, but they won't really know where I want to end up going. All they know is that I'm using Tor. So what's going to happen is I connect to a first Tor node, and my traffic is sent from that Tor node to another Tor node, and then from there it's sent to another Tor node. Finally, from that last computer, my data is actually sent to the web server. So if the web server wanted to know what kind of users are using its service and where they're coming from, now they don't really have an idea of where I'm coming from, because all the traffic that's going to that web server looks like it's coming from that last Tor node. Yeah?
How can you trust the nodes? They can be government.
Right. So I mean, yeah, they're all going to be volunteers, and I'll kind of go into a few examples of where you might want to not trust them, but it's a good question. Okay, so also, I just wanted to mention that every one of your links is going to actually be encrypted. So let's say I'm Alice and I'm sending data through the Tor network to Bob's server. Well, my client is going to encrypt my traffic to the first hop, and then that traffic is encrypted before it goes to the next hop, and then that traffic is still encrypted when it goes to the third hop. But then when it gets to the last hop, it's going to be decrypted to plain text, and that plain text is going to be traveling through the internet to Bob's server. So Tor kind of encrypts your traffic, but not completely. And the reason why it doesn't encrypt the last hop is because the web server still needs to be able to decipher whatever you're trying to send it. So if someone happens to be kind of spying in on your connection between the last hop and the web server, they'll be able to read your text in plain text. Kind of like what I did in the last meeting with my demo. So just a few quick terminologies. The first node that I connect to here, or actually, let me start with the other ones. This is the last node, and that's where my traffic is actually going to exit from. So we call that an exit relay. all of the nodes in this Tor network we call relays. The nodes that I connect to in between are called middle relays. And the one I enter from is called a guard relay. So I don't know why they didn't just pick entrance relay, but we call that a guard relay. So anytime we make a connection through Tor, it's basically going to go from guard to middle to exit relay, and then finally to our destination web server. Okay. So this is kind of what I was saying. The client encrypts, actually let me move it back because this is sort of important. So exactly how does it encrypt the traffic? Well, with Tor, anonymity is really important. So we don't want any particular hop to be able to compromise the flow of traffic through that hop. So the middle node should still not be able to understand what traffic is going through it, and neither should the exit node, and neither should the entry node. So the way we're going to do that is by a series of encryptions. So the first encryption that my client does before sending the data is it's going to encrypt the original data in such a way that only the exit node can actually understand it. So only the exit node will be able to decrypt this data, but the entry and the middle nodes won't be able to. On top of that, my client will also encrypt it in such a way that only the middle node will be able to decrypt my data. So now, even if my, let's say my entry node gets compromised, it will only know that I'm trying to go to some middle node. It won't know what my exit node is. And then finally, outside of that, we encrypt the data that was created from the first two steps so that any data going from my entry node or from my client to the entry node is encrypted, so no one who intercepts between that will really understand what the data is or the fact that I'm trying to go to a middle relay. And this kind of like layers of encryption idea is why we call it Tor, or an onion routing protocol. So every layer of data is encrypted with a new layer. And then when we go to a new layer, it becomes kind of peeled off by that node that we go to. So this is kind of the essence of how Tor works and how it encrypts your data and how it sends it to your final destination. So just some random interesting facts that I found while looking this up. It only runs TCP streams, and that kind of makes sense. You don't really want random packets to be lost along all these trips. Some of these hops are in different countries, so running something like UDP might not be very reliable because it'll probably get lost eventually along the way. Another fact that I thought was kind of interesting is you don't want to be reusing the same circuit to get to your destination all the time. Otherwise, we might be able to trace your attacks. So the Tor circuit actually automatically changes your circuit every 10 or so minutes. And then there are some websites that only accept connections through Tor. So these websites we call Tor hidden services. So their existence is because they want their users to remain anonymous. They don't want to know who's connecting to them. And colloquially, you might know these kind of websites as the dark web. So a typical website on the dark web, or a typical website on a Tor hidden service, ends with .onion. I don't know how visible that is here, sorry, but this is how it typically looks like when you type it into your browser. It's going to be a bunch of letters and numbers and then .onion. Yeah, so if you do find an onion website that you want to visit, I will just caution you to be very careful about visiting them. Not only because of their content being somewhat questionable sometimes, but a lot of them are scams and viruses. So if some service is offering to take your bitcoins and double them, you're probably not going to see that again. Also, be careful when you try to image search dark web. That was a thing I learned. Another interesting thing is there's actually about 6,000 relays currently in Tor. So depending on how you want to use it, that's actually pretty interesting information. Okay, so I mentioned a lot about how Tor anonymizes you from source to destination by kind of hiding your IP address. But there are kind of some workarounds that you might not have thought of, or maybe you did think of while I was going through them. So, for example, my ISP sees that I'm connecting to Tor. Why can't it just trace my route through the Tor network and find out where I'm trying to go? And I kind of went over that when I was talking about how each layer of data is encrypted. So each node doesn't know anything about where the data came from originally or where it's trying to go to ultimately. All it knows is the previous hop and the next hop in its journey. So this is kind of a nice thing about Tor. It's hiding the data. Even if one of the nodes is compromised, it doesn't really give away what's happening. Okay, fine, we accept that. What if I go to a country or some area where they know that Tor exists and they don't want their users to be using Tor to anonymize themselves? How can I get around that? Why does that concern come up? Well, all the Tor node IP addresses are publicly available and known. So if I see that maybe one of my friends is just connecting to an IP address which is on the list of Tor nodes, I'll know that he's trying to access Tor. So I'll just block any incoming connections with some kind of firewall. How do I get around that? How can I still connect to Tor even though these Tor nodes are publicly listed? And the way we do that is with this thing called a bridge relay. So a bridge relay is just a specialized type of entry node into the Tor network. They're not publicly listed, but a database of them is maintained by the Tor project, the people who basically run Tor right now. So if you want to connect to Tor kind of discreetly without whatever organization or country you're in to know that you're connecting to Tor, you can actually send an email to the Tor project and request a few bridge relays for you to start your connection to Tor through. So ideally, they're not really well-known IPs. So if anyone was trying to just mass a list of bridge relays, they wouldn't be able to do this. And the Tor project kind of tries to enforce this by only letting you send the email to request a bridge relay through Gmail or Yahoo. Although I find that a bit questionable because I've seen a lot of spam come from Yahoo, but no hate. So if you do this, you can basically get access to a bridge relay, which is an unlisted Tor node, so you can connect to Tor without people actually knowing you're on Tor.
Going back to how that Tor actually works, so does the client know the other route that it's going to go through, so they can encrypt through their public keys or something? Like how does the client know how to encrypt it for all nodes?
So there's kind of like a Tor directory that it's kind of like a DNS server for Tor. I don't remember the exact specifics of how it actually gets the keys for each one, but it'll basically determine the route before it even sends out the traffic through the circuit. So it's not kind of dynamically figured out. It is some kind of service that it goes to and finds out what kind of available routes can I take. Yeah. Okay, so that was one of our other concerns. How can I use Tor in a nation or area that doesn't really want me to use Tor? And the way to get around that is using bridge relays. Finally, one of our other concerns is any one of you could go home and just start running a Tor node right now if you wanted to, in the name of anonymity or whatever you want. Now, what if you happen to start running an exit node? So this is a valid question because if you're running an exit node, it looks like a lot of shady traffic is coming from your IP address to whatever web servers are running this shady things. So a lot of exit node people, and the answer to that is yes, you will get shady traffic coming from your computer. So exit node, people who run the exit nodes actually end up getting quite a few calls from like the federal government and receive quite a few DMCA notices and abuse complaints. Unfortunately, there's not much you can do about that other than, if you're gonna run one, try to run it in a country that doesn't really care, or find an ISP that doesn't really care. If you do know anyone who runs an exit node, give him like a nice thank you, because this wouldn't work without him. But so the last kind of concern that I thought you might have is, we mentioned that every hop is going to be encrypted in the Tor network, except for the last hop to the web server. So all of that is in plain text. If you're giving away data that might give away who you are, you don't want that to be available in plain text from the last hop to the web server that you're going to. So whenever possible, try to use Tor with HTTPS. And if you actually use the Tor browser to use Tor, it'll kind of default to HTTPS traffic. Okay. So with that in mind, what are some times when Tor actually failed us? The first example I found was actually from just a few years ago, and involved this interesting little student at Harvard. So there was a student at Harvard by the name of Eldo Kim, and like many of us at Tech, he wanted to get out of a final.
Oh God.
So what he decided to do was he sent an email proclaiming that there were 2 bombs hidden on their campus in 2 of 4 rooms. And his email essentially said, guess which ones? But so he decided he would be a bit smart, and he wouldn't just use his main IP address, because the service he was using to send the email, I think it was called like Gorilla Mail, their requests actually record the IP address that the email came from. So he decided to use Tor to try and send this email through. But there were a few issues with what he did. First of all, he didn't use a bridge relay. So the fact that he was using Tor was known to whoever was on his ISP, or whatever ISP he was using, because he was connecting directly to the Tor network. So if there aren't many other users on the network you're using that are also using Tor, it's kind of easy to pinpoint who was using Tor. So you'd think that he would use a network where maybe a lot of people are using Tor at the same time. Instead, he decided to do this on his campus Wi-Fi. So yeah, this was a pretty easy catch for the government and the police. They were pretty much able to find out who was using Tor at the time that this email was sent, and obviously it was the guy who was logged into the internet on his ID going through Tor. In his defense, he did like profusely apologize about what he did, despite it being dumb, but at least he tried to be smart. Okay. Yeah.
Sorry, so going back to the HTTPS.
Right.
So, like, my understanding is the exit node is the one making the request to the web server, right? So I don't know too much about how HTTPS works, but why couldn't the exit node, like, do something with, like, the certificates or whatever so that it could see the unencrypted traffic? Like, what's preventing it?
So, are you asking like why can't the exit node just look at the traffic that's being sent?
Because it's the one making the request to the network.
So technically it's actually your client that's making the request. So you encrypt the traffic before you even send it to the exit node using HTTPS. No different from how you would be doing it right now from your computer to an internet website. The only difference is it's being routed through all these nodes, and then the final request is made from that IP address. Okay, good question though. Okay, here's another time when Tor was kind of a failure to its users. How many of you have heard of lulsec in any form? Okay, that's a fair amount. So lulsec, for those of you who don't know, was a black hat computer hacking group. It operated a few years ago, and they were pretty notorious for hacking random websites. Like, I think they once defaced the CIA's homepage. And they also attacked Nintendo. So, I mean, who attacks Nintendo? That's when you know you've messed up as an organization. But anyway, they kind of were run by this guy named Sabu. No one really knew who he was, but he did go on this IRC server to chat with his fellow hackers to kind of communicate the plans for the organization, what their next target was, etc. So when he tried to connect to this IRC server, he always used Tor so that no one would be able to see who he was. Well, one time he got lazy and he didn't. And that one time was enough for the government to be able to trace him and his IP address to find out who he was. The other thing is, when he was on the IRC server, he tended to post kind of personal details about himself that would end up revealing who he was. So I mean, Tor is a great service, but if you're going to tell the world who you are, there's not really much that it can do for you. So eventually they found him and kind of took it down. But lesson learned, don't get lazy if you're going to try to be anonymous, and try not to be posting personal details and using personal accounts.
And later on he turned his teammates in for a plea deal.
Right, that's another thing. If you're going to work with something, make sure it's like someone you trust. That guy basically, what he said was, after he was caught by the FBI, he ended up just telling the FBI who he's working with, like all his team members. So then they all got arrested. So.
And they were like 20 while they were hacking FBI and CIA.
Right. Although I think he's already out of prison, so justice, right? All right. And the last case study I wanted to go over was the Silk Road. So I'm willing to bet most of you have heard of the Silk Road. Silk Road was another Tor hidden service that you could only access through Tor. And it allows you to do things like access illegal drugs to either purchase or sell. So it was run or created by this guy named Dread Pirate Roberts, as his screen name was. And it was interesting. It was kind of slow in the beginning, as many web servers would be, but it started to pick up notoriety as they started noticing large cash flows. Namely, when the feds realized that over $1 billion was being funneled through this website, they started to get interested and started trying to do some research on how to take it down. So in order to do that, they tried to find some of the earliest references to the Silk Road online. And the first place that came up was on this website called the Shroomery. Can anyone guess what's on the Shroomery? Yeah, so the Shroomery is just a website where you could purchase mushrooms if you wanted to do that for whatever purpose. And they had some kind of forums so that you could also talk to other members on the site. And there was this user whose name was Altoid, and this was the first kind of reference to the Silk Road that the Fed government was able to find. They basically saw this guy named Altoid saying, "Wow, guys, there's this cool website called the Silk Road. Has anyone tried it here?" And it was like a question, but it was pretty obviously also kind of an advertisement for it. But shortly after that, there was another website called Bitcoin Talk, and they also have forums where, again, a user named Altoid decided to kind of ask around if anyone had used this cool new service called the Silk Road for whatever their needs. A little while later, another post came up on Bitcoin Talk by Altoid, and he was asking people, "Hey, does anyone know if you have any IT expertise? I would really appreciate your help in setting up this website for the Silk Road. And if you could help me out, please just contact me at rossolbricht@gmail.com. So, again, good job. So, this was kind of a big giveaway to the feds, like who is running the Silk Road. But if that wasn't enough, later on a question came up on Stack Overflow about how you can connect to Tor hidden service using PHP. And guess who it was asked by? Ross Ulbricht. So I guess he got kind of clever and he decided to change his name to Frosty later on. I don't know why. But by that time, I mean, the feds had already found out like who he was, and they were able to start tracking him. So the kind of common trend Oh, by the way, you can still visit that link, which is kind of cool because you know that it was the founder of the Silk Road who asked that question, who got arrested at some point. But the common trend between most of these attacks or failures of Tor that I've went through is mainly been user error. So, and this is kind of like a trend across security in general. Like you can have a great service or system that works great in theory, but if your implementation is wrong, then there's not much that anyone can do to help you. So that kind of begs the question though, are there any actual attacks against Tor? And if so, what are they? And is Tor still safe? So the most common kind of attack you might hear when talking about Tor and its vulnerabilities is correlation attacks. And a correlation attack is pretty simple in its kind of essence. So you're talking to your ISP, you're going to the first hop on your Tor network, and let's say you just send 21.1 megabytes of data, and that means basically 21.1 megabytes of data are coming out of the exit node as well, minus the encryption and all that. So if, let's say, some kind of malicious party owns these last two, or sorry, the first node and the last node in the Tor network, then they can basically correlate the fact that from your IP address, I received this much data and this much data came out on the other end. So it seems pretty plausible that this guy is trying to access this website. And this is kind of one of the main attacks that you can do against Tor, but it's sort of hard to implement because you kind of have to own enough of the Tor relays to be able to implement such an attack. So what the Tor community has done to kind of counteract this is introducing something called entry guards. So it basically boils down to just using probability to assure the user that they're most likely going to be secure or anonymous when they visit these websites. So it basically, the solution is pick a few random nodes that you're going to connect to and use those as your entry relays, which seems like an obvious thing to do anyway, but if your handful of nodes never changes, then as long as most of those nodes or a majority of them remains to be non-malicious or not owned by anyone looking to de-anonymize your traffic, then the majority of the time they're not going to be able to de-anonymize your traffic, even if a few of them are compromised. So it's not 100% guarantee against correlation attacks, but it's kind of better than nothing, and for the most part it seems to be working. Some other attacks that have been coming out recently, or in the past 2-3 years, there was actually a pretty interesting article on Ars Technica about this that you can also check out later. But there was some research done at MIT where they tried to own just a lot of the entry guard nodes, or the nodes that kind of you're choosing to go into the network through. And what they did was use ML and deep packet analysis to kind of find out what kind of circuits you're using to get through the network. And it was pretty interesting. It was able to kind of accurately predict your circuit with 99% accuracy. I think it was because of some bug through their code, but I think the Tor project was able to fix through that. Another attack was actually done by CMU. So the details on this one were a bit murky because they kind of went around, the researchers kind of went around announcing, hey, we broke Tor, like we can find out who people are now. And then they were supposed to give this talk on Black Hat, and then a month or two before they just canceled their talk mysteriously, and they wouldn't tell us how they broke Tor or what they were able to do. Although the rumors are kind of something along the lines of injecting tags into each of the packet to trace the route through the Tor circuit. It still hasn't really been revealed, as far as I know, how CMU supposedly broke it. And there's a lot of controversy surrounding this too, because people think that the FBI is the one who paid CMU to conduct this research. But as far as what we can tell, apparently the NSA has been able to de-anonymize Tor traffic for years and hasn't really said anything about it, but it's kind of up to you if you want to decide to continue using Tor at your own risk. Some of the research I've seen today kind of involves looking at some of the networks that can be created with Tor nodes and Tor relays, and using some graph algorithm analysis to find out if you can de-anonymize flows going through the network. Okay, so that was all I had on Tor. And the other thing I said I wanted to just kind of give you a cursory glance at was VPNs. So how many of you have actually used the Georgia Tech VPN, for example? Right, so a lot of you have an intuition for what a VPN does. It's basically a service that lets you connect to a computer on a different network and make it seem like your traffic is coming from that network. So I could be at my house in New Jersey and use a VPN to connect to Tech's internet, and then whatever my internet traffic is doing makes it seem like it's coming from Georgia Tech's Wi-Fi. So this is kind of interesting principle because it allows you to hide your geolocation amongst other things. So I know while people were in Europe for my study abroad program, people were using VPNs to get around Netflix restrictions or other things. So the other important thing about VPNs though is that any traffic you send through it is encrypted. So anyone kind of tapping in on the connection between you and your VPN provider can't just see the traffic you're doing. So VPNs also kind of seem like an interesting way to get around the whole anonymity problem. But you know, if we have Tor and if we have VPNs, why not use both? So one of the most famous questions about Tor and most popular questions about Tor that's asked all the time is, should I use a VPN into Tor or should I use a Tor to go into a VPN? And really there's no answer to this. You could do either. Each one has its own kind of advantages and disadvantages. Ultimately, at the end of the day, your VPN provider is sending your traffic to wherever you're asking them to. So for one thing, you're going to have to trust your VPN provider to not give you up if they end up getting a request from the government or any other entity. From what I've heard, if you want a reliable VPN provider, there's these things called bulletproof VPNs, and specifically they advertise themselves as this, as we won't give up your info if the feds come knocking on our doors. But you know, at the end of the day, if it comes down to them going to jail versus you, they're probably going to choose you. So one of the most popular places I've heard of for good VPN providers to go anonymous are in the Nordic countries and kind of Eastern Europe. I don't know why. I guess it's just the laws they have there. So like I said, there's no like kind of shorthand rule for which one should I use. Should I use a VPN to go into Tor or vice versa? But they're both going to give you some kind of level of anonymity to try and accomplish what you're trying to do. Okay, so that was like most of the presentation aspect that I wanted to go through with you. And so I just want to show you a quick idea for what the Tor browser is and kind of what it looks like. So one thing, if you're gonna access some website on the deep web or wherever using Tor, make sure you try not to do it from a root account. So it's best if you do it from something like a virtual machine, because like I said before, a lot of these Tor hidden services tend to be scams or have viruses or something else. So if you're going to access them, it's safest to do it from a virtual machine where nothing is going to be permanently residing on your machine. And on that virtual machine, it also helps if you're going to use a non-root account, so nothing too much can be compromised. So after saying that, I'm going to ignore all of that and just do it on my computer because I know where I'm going. So if you go to the torproject.org, you can download this Tor browser, and the Tor browser allows you to just connect to the Tor network. So what you saw me doing there is clicking the Tor browser, and all it did was double click, and it established a circuit and set up all the encryption keys that I mentioned before. So So once that starts, it looks like just like any other browser. Maybe Firefox. I think it's a version of Firefox. And you can basically visit any website you want to now. So as an example, I can go to google.com. Now, since I'm routing it through all these Tor relays though, it does tend to be a lot slower. And you'll also notice that any geolocation preferences I might have had are gone. So I'm loading Google France now because my Tor browser is kind of routing my traffic through France right now. And Google thinks I'm in France, so it's giving me a French version of their page. You can also see exactly where you're being routed to if you click here. So my browser is sending its traffic through Romania to the Netherlands, to France, and then finally going and requesting the site from someone's machine in France. So thank you, whoever. And you can also try and manually request new identities if you feel like you want to get a faster connection or whatever. And I guess just a quick demonstration of accessing like a .onion site. So there are lots of various .onion sites that you can actually go to. If you look up this thing, so with whatever knowledge I'm telling you today, by the way, be very careful about what you're doing and where you're searching, because you might not know what you find or even if it's real. But one of the things I will tell you for knowledge's sake is there's this thing called the Hidden Wiki. And this isn't it. This is just a website that copy and pasted stuff from the Hidden Wiki. But the Hidden Wiki is a Tor hidden service that kind of lists a bunch of Tor hidden services that you can visit for whatever purposes you might need. Some of them are pretty scary. You could hire like hitmen on some of these sites if you want. And there's a lot of like drugs and whatever you might be able to think of. I will say that a lot of these are probably fake or taken down if they're kind of just hosted on the open web here. But this wiki does exist, and the URL for the Hidden Wiki constantly changes because of the fact that it keeps getting taken down. So always be careful if you're just trying to explore these and trying to learn some of the stuff that's out there. So I'm not going to visit any of these links because I don't want to. I will show you that Facebook has actually allowed you an option to connect to its website through Tor if you need to do so anonymously. So yay, thank you Facebook for having a Tor website address. So I just Googled their Facebook onion address and I can type it in on my browser here and paste it. And if it works, I should be able to get to the Facebook page like normal. Although if you're going to end up signing in using your username and password, in a sense you're kind of compromising your identity there anyway. The purpose of having the Facebook Onion website is maybe if you're in a country that doesn't want you to use Facebook, this is a way you can access it. So with that said, just some final parting advice. If you're going to try and connect to the Tor, try to do it through the Tor browser instead of using any third-party applications or even making your own. The Tor browser comes with lots of default presets, settings that try to anonymize you to the best of its ability. There's so many ways that you can trip up in anonymizing yourself, and I mentioned just a few of them in this presentation. The browser is run by the Tor project, and it helps kind of alleviate some of these issues as much as it can. One of the cool, interesting things that I found when I first started using the Tor browser was it warns me when I try to maximize my screen for the browser. So apparently just maximizing the screen of the browser to take up the size of the screen is actually leaking data about who you are and what you're doing. So it's like small subtle things like that that you might not have known about that the Tor browser comes with safeguards against for you. So 99% of the time if you're using some other service that connects to Tor, it's probably not as safe. Okay, a lot of you have probably torrented something at some point in your life, and now that I've shown you how to anonymize your traffic, a lot of you are probably thinking, great, now I can get all my music anonymously. No one will know that I'm torrenting anything. Don't do that. Aside from the fact that it's wrong, and that we're stealing money from people who worked hard to make it, torrenting, many torrenting applications tend to kind of avoid the proxy settings on your machine. So they'll actually just bypass the fact that you have a Tor connection open and make a direct connection to whatever you're trying to get the torrented files from. So if you're gonna do that, I mean, it's up to you, obviously. I can't force you to do one way or another, but I can advise you not to. Don't enable browser plugins. So these are kind of like obvious tips that you might hear anywhere, but really, like, these are the kinds of things that, as small as they are what trip people up, because these are the things that give up information about your browser and where you're coming from and what you're doing, and send them over the network to whoever is kind of listening in on your connections. Obviously, use HTTPS. I fully support Google in that it's now prioritizing HTTPS websites in its PageRank algorithm over HTTP, because frankly, everyone should be using HTTPS. It's not a hard thing to implement. Don't open documents downloaded through Tor. This seems also like fairly obvious advice, but as I said before, many of the sites are very scammy and kind of fake. A lot of them will have kind of malicious documents that might run or execute code on your machine. So if you do want to download something, do it with your network settings off inside a virtual machine. That's probably the safest way. You could also use some very secure operating systems like Tails, if anyone's heard of or used Tails. Tails is a Linux distro which attempts to anonymize you to the maximum ability it can. And obviously, if you're in a country that doesn't support Tor, use a bridge node. All you really need to do is request the IP address of bridge node, and you can set that as your default for whenever you're trying to enter. And they'll typically send you a few.
Can the malicious code jump out of the virtual box and to actual machine?
So if we could do that, and if it could find out that it's inside a VM, then a lot of security companies would be in trouble right now, because they kind of rely on virtual machines to be able to test a lot of their malicious code that they kind of sample. And if you could kind of develop a malware that knows it's inside a virtual machine and it just remains dormant, and then if it gets placed on a real machine, it remains active, then you're kind of in trouble. And so I don't know specifically how many malwares like that, if any, exist today, but I do know it would be kind of a problem. Yeah.
This is more just a general comment about BitTorrent. BitTorrent uses a combination of TCP and UDP. UDP is mainly used for peer discovery as part of their DHT protocol, or an extension to the protocol. But Tor only protects against TCP traffic.
Right.
So if you're discovering peers, you're screwing yourself over.
Right. So that's actually a great point. Thanks for bringing that up. So I mentioned that before too. Like, Tor only supports TCP streams. So if your torrenting clients are actually using UDP to find what peers it can connect to, you're giving yourself up right away there. So thank you for bringing that up. Yeah.
Actually, malwares can jump out of the VM. It's called the VM escape.
Okay.
It's a thing.
Yeah. Malware is advancing pretty fast, so I'm not an expert in that area, but it's a pretty interesting thing to look into. But yeah, that's all I had for today. Thanks for coming again and listening to me, but good to go.